this problem, you have given a grid. It's a binary grid that basically contains only zeros and ones. You have to transform this grid into another grid where each cell contains the distance from that cell to nearest to zero. This is the first cell. So distance 0 from this cell is basically 0 because it's a 0 cell. But for this one, distance to nearest 0 is 1, either this 0 or this 0. So it is 1. It's basically kind of Euclidean distance. For this 0, it will be 0. For this one, it will be either the top one or the bottom one. So the distance is 1. But for the central one, it is 2. So you have to pass through 2 cells to reach at any of the nearest 0 possible. So it will have 2. For this one, there will be distance only 1 because it has a neighboring 0. So it will be 1. Here it will be 0. Here it will be 1. Here it will be 0. This is the final result you will be expecting. You have to transform the input into something this output based on the distance of 0. So let's walk through the code and see how it. See, it's a more detailed explanation. See how it really can be programmed using C++. So let me update the test case as per what I had given in the sample. So it will be easy to compare. Now how we go with this problem? The only thing we can do, we can use breadth first search. Breadth first search, what it will basically do, initially for every breadth first search, there will be kind of layering. Once you initialize the initial nodes you are going to explore, it will on its first iteration, it will explore the layer 1, which is associated with the nodes initialized. So I will simply write the steps that we will be following to do a breadth first search. So first initialize the points once we are going to explore, and layer the distance of exploration, 8 points, then do normal BFS. So initializing the first point means it will be like we'll be using these zeros because distance from these zeros will be easier to see. If you're starting from this 0, when you do BFS, you will be exploring this point, then this point, then this in the these 2 points in the first step, because you can either move to right or you can move to left. You don't have diagonal movement. So since it's a kind of Euclidean movement, so it will be on right or left. So you understand that they are at 1 unit away from your current 0. Once you explore these 2 points, you will be enqueuing these 2 points. At that time, you will increment the layer by 1. So suppose if you are here, if you are here and you are exploring this point, currently you are at L1, layer 1. When you reach here, you will be at L2. You will be at L1. When you reach here, you will be at layer. So the distance from L1 to L2 is 1. From L0 to L1, it will be 1. So the net distance goes like 2. That's the way we calculate the distance from 0. So at L0, we'll be having only zeros. These zeros, this one and this one. In the queue, that we will do first. We have to initialize a queue. Okay. Now I iterate through. 0, enqueue that. If matrix ij is equal to 0, enqueue that point. Now we have all the 0 points enqueued. We will start doing breadth first search. To that, we have to define our layer. Currently, we'll be exploring the layer 0. Layer 0 has a size, q.size. While layer 0 is incomplete, we'll be popping the elements from the queue. Q. So you have 2 elements. Now what to do next is like you have popped out. Okay, you had not really popped out the queue. Now you have popped out the queue. Now you have an element at your hand. You have to explore it. Before that, you need a visited array. You need a output array. So your output array like this will be output array. We will initialize all of the distance with 0. Then you need a visited array equivalent to output array. So you don't need to visit them again. So what you will make the visited array, and we will mark visit like say equal 1. Okay, that concludes it. Now you have to explore the neighbors of your current point, current cell. For that you need some iterator to ensure that to make you rotate over the cells around your current cell. So rotate it. Now you need the neighbors coordinates. X plus t. So you receive the neighbors coordinates. If the computed neighbors coordinates overflows the boundaries of our system, our matrix is used. Continue. Otherwise, you have to enqueue this point. You have to enqueue this point for further exploration. You have to mark this point as visited. However, if it has visited also, you will not be visiting it again. Okay. Now, once you go through a layer of exploration, you have to increment the layer. Every time when you reach at some point, this is your result array. Every time when you explore a point, you have to update that layer as its distance from nearest to 0. So this shall give you the answer of what you're expecting. Let's run. Yeah, 0 1 0 1 2 1 0 1 0 1 0 0 1 0 1 2 1 1 0. Both answers are matching, so our venturing is landed at correct location, correct target. Thanks for listening.